Assalamu alaikum. It's our fifth lecture on FDE EST Physics preparation. We already covered first four lectures regarding EST Physics preparation, which is the most repeated MCQs in all past previous EST exams. So by doing these MCQs, you can easily score 90% of your paper. Okay. So these are total of for physics only. This is of total. You can see 96 pages of total. We made this for you for quite easy to learn. And these collection of 96 pages of EST physics MCQs are the most unique and the most common and the all repeated past MCQs which mostly came, and by doing this all MCQs, we surely that you could easily score 80 to 90% in your exam. So if we will cover all these lectures day by day, like we already did first four lectures in previous. If you forgot to watch, you can watch those lectures first, then move on towards this fifth lecture. In today's lecture fifth, we have gonna start chapter number 5, which is about the wave motion, and in next videos we will cover the remaining 6, 7 and 8 chapters also. So these are the main chapters and the all syllabus comes from these chapters. Okay, so we will cover all those in our videos, but if you feel that you want these notes physically, so I should left my WhatsApp number as well as my channel link in the description below. Channel link is for we will update their jobs about regarding tests, regarding upcoming events, regarding tests, all the way we will update there. And if you want to directly contact me, you can directly message on my WhatsApp number if you want these notes. I will surely provide you in a very little price. Okay. So let's start our today's lecture number 5, which is about the wave motion. So first of all, you must have to know what is wave motion. So let's start. Basically, waves are disturbance in a medium. Okay, what is wave? So you can define it like wave is a disturbance in some medium. Okay, disturbance like transfer energy from one place to another in the form of matter. Okay, waves can be classified based on their nature and the medium through which they travel. So wave travel in mediums. Okay, without medium wave, your wave do not propagate. Okay, so there are some types of waves, like first of all the mechanical wave. So wave that requires a medium like solid, liquid, or gas. Those types of waves require some medium to travel. If the medium is not available, then your wave should not travel, like sound waves or water waves or seismic waves. Okay, so these are all the mechanical waves. So all types of mechanical waves, those who needs medium to travel are called the mechanical waves. Okay, so mechanical waves you can say in simple require medium to travel. Okay, so subtypes in mechanical waves are transverse waves and longitudinal waves. So transverse as well as longitudinal both are the mechanical waves and they require medium to travel. Understood? So in transverse wave, the medium's particle move perpendicular to the direction of the wave propagation. Okay, so in transverse wave, your medium particle move propagate perpendicular to the direction of propagation of, okay, like water waves or electromagnetic waves. Those both are the transverse waves. Those require medium to travel. Like electromagnetic wave, these need to medium to travel, and are the waves in which the medium particle are perpendicular to the direction of the wave propagation. While in longitudinal wave, the medium's particle moves parallel to the direction of the wave propagation, like sound waves. Okay, so sound waves are longitudinal waves, while your electromagnetic as well as your water waves are the transverse waves, and all these are the mechanical waves, means waves that require medium. Understood? Now move on towards the electromagnetic waves. There is a slightly error. This is that electromagnetic waves do not require medium to flow. So this is wrong here. So let me cancel this. Electromagnetic is not inside transverse wave, because electromagnetic wave is basically a light photon, and light do not need any medium to propagate. Okay, so only water wave are transverse waves, and your sound waves are the longitudinal waves. Understood? Now move on second type of wave, which is, now you can see this is electromagnetic waves. Okay, so electromagnetic waves which do not require any medium, mechanical wave which require medium, and electromagnetic wave which do not require any medium to travel or to propagate. Okay, like light waves, radio waves, X-rays, gamma rays, okay, UV. These all are the electromagnetic waves, and they do not require any medium to travel. Now, what are their characteristics? So, they composed of oscillating electric and magnetic field, and they are perpendicular to each other. Okay, and these waves are composed of oscillating electric and magnetic field. In these electromagnetic waves, there basically the propagation, and there is a fluctuation of electric and magnetic fields. Okay, and that are perpendicular to each other to the direction of wave propagation. Now move on third type of wave, which is the surface waves. Waves that travel along the surface of a medium, like as I mentioned you before, water waves. Water waves move parallel, those are mechanical waves. But what are surface waves? Waves that parallel along the surface of medium. So that waves that travels on the surface of medium, not in depth, only on surface. So like ocean waves, you can see they travels on the surface of ocean, and surface seismic waves they travel on. Okay, so these type of surface waves are called as the surface waves. And like characteristics, particles move in circular motion. Okay, so these are, so what are the key concepts of this? In waves you must have to know about the amplitude, you know about the wavelength, you have to know about the frequency, you know about the wave speed. Okay, so that's all the key concepts. So first of all, what is the amplitude? So amplitude is basically the maximum displacement that a particle can that a particle from the rest position. So from the main position or from the rest position, the maximum displacement that a particle should cover is called, or a wave travel, wave cover the maximum amplitude displacement is called the amplitude. Higher amplitude means more energy, very important. The more the amplitude means more the energy it has. Next, move on towards wavelength. What is wavelength? The distance between two consecutive crust or trough, you can say, or you can say two consecutive points in phase of a wave is called wavelength. Okay, so the distance between two consecutive crust as well as trough is called as the wavelength. Okay, so on to the frequency. What is frequency? Basically, the number of waves per second is called as the frequencies. Okay, and the unit of frequencies is hertz, and the minute unit of wavelength is meters. Now, what is wave speed? Wave speed is denoted by V. Okay, the speed of the wave. Though, so how you can define the speed of the wave? The speed at which your wave propagate is called the wave speed, and the formula for the wave speed is V is equals to F lambda. So a product of frequency and lambda is basically the wave speed, and frequency and the lambda are the inverse relation to each other. If more frequency means less wavelength, if less wavelength means more frequency it has. Okay, now move on towards the multiple choice questions, which are the most repeated past EST Physics MCQs. By doing these, very quite easy for you to solve the exam. Okay, so which type of wave require a medium to travel through? So which type of wave medium to travel through? So we know that mechanical waves require medium to travel. Okay, in which type of wave do the particle of the medium move parallel to the direction of the wave propagation? We know that longitudinal waves basically move parallel to the direction of the propagation. Which of the following is an example of transverse wave? We know that basically light wave is a transverse wave, while sound, seismic, and compression are the longitudinal waves. Okay. What is the unit of frequency? We know that it's hertz. Okay. If the wavelength of wave is 2 meter and its frequency is 5 hertz, what is its wave speed? And so this is only product. So wave speed should be product of lambda and frequency 5 to the 10. So it becomes 10 meter per second. Okay. Answer is C. Which of the following statement is true about the electromagnetic wave? So we know that they cannot require means electromagnetic wave do not require any medium, so they require a medium, so this is wrong. They cannot travel through vacuum, they can travel, so this is also wrong. They can composed of oscillating electric and magnetic field. Yes, we know that electromagnetic field is a combination of both the oscillation of electric as well as magnetic field, which is the maximum displacement of particle from rest position is called the amplitude. Okay. uh, Ocean wave are an example of which? Ocean wave, we know that is an example of surface waves. Okay. Which type of wave is a sound wave? Okay. Electromagnetic wave is not a sound wave. Transverse wave is not a sound wave. Yes, longitudinal wave, mechanical waves basically are the sound waves. Okay. At distance between two consecutive crust and stuff is we know that is the wavelength. Now move next. We know about the wave speed. We already know what is wave speed, frequency and wavelength. Wave speed is basically the distance that a wave travel per unit time. And the formula again V is equals to f lambda. Frequency unit is hertz and wavelength unit is meter. And frequency is basically the number of wave per second. And frequency is also the reciprocal of time period. Okay. And wavelength is the distance between two consecutive crust and trough. Okay, we already did this. Types of waves, mechanical waves and electromagnetics, we already discussed this. Okay, now move on towards our main multiple choice questions. The speed of wave is calculated by multiplying its frequency and wavelength. So the correct answer is B, wavelength and frequency. Okay, which of the following is the correct formula for the wave speed? We know that V is equals to f lambda is the correct. If the frequency of wave is 10 Hz and its wavelength is 2 meters, what is the speed? We know that 10 multiplies by 2 it becomes 20, so 20 meter per second. Okay. So the distance between two consecutive crust and trough, we know that it's the wavelength. What is the unit of frequency? We know that Hertz is the unit of frequency. If the wave has a speed of 30 meter per second, this is the speed and the wavelength is this. What is its frequency? We know that V is equals to f lambda and f becomes equals to V by lambda. So V is this divided by lambda 3. So 300 divided by 3 becomes 100. So the correct answer is answer A. Okay. The period of wave, the period of a wave is the what is time. What is the period of a wave? Period means the time it takes. So the time it takes to complete one complete wave. Okay. So basically time period is to complete one wave is called the period, or you can say the time period. The correct answer is the time it takes from one complete wave, okay, to pass to a point. If the wavelength of a wave decreases and its speed remains constant, what should happen to frequency effect? If wave is decreased, so frequency must be increased because there is an inverse relation of between wavelength and frequency if your speed remains constant, because we know V is equals to f lambda. If V remains constant and if wavelength is decreased, so definitely frequency should be increased. Okay. If a wave has a frequency of 50 Hz and its period should be 1 by 50 and 1 by, because we know that frequency is equal to 1 by t, okay, 1 by time period. So if you want to find period, so it becomes 1 by t equals to 1 by f means 1 by 50. So 1 by 50 is 0.02, okay, seconds. Now move on towards our next topic of this chapter, which is about electromagnetic waves. Okay, what are electromagnetic waves? In electromagnetic waves, we'll discuss about the spectrum of electromagnetic waves. We will briefly describe about the spectrum of electromagnetic waves, because there is a whole spectrum of electromagnetic waves, from radio waves to microwaves to UV, infrared, visible, gamma rays, X-rays, and so on. These are all the waves spectrum. Okay, so what are electromagnetic spectrum? The electromagnetic spectrum encompasses all types of electromagnetic radiations arranged according to their wavelength or frequency, and those are properly arranged according to their wavelength and frequency. So you can watch by just typing in Google electromagnetic spectrum. You can see how beautiful that spectrum is. Okay, if its range from very short wavelength gamma rays to a very long wavelength radio waves. As I mentioned you before, gamma rays are the most energetic waves, and more the energetic means less the wavelength, because you know that there is an inverse relation of E and lambda. E is equals to hc by lambda. You know that this relation. Okay, E is equals to hc by lambda. So if energy is most, so lambda should be very low, because gamma ray has the most energy, so their wavelength is very short, and because the radio wave has the very low energy, that's why their wavelength is very high. Okay, so key regions for the electromagnetic spectrum, you must have to know about the gamma rays, you know about the X-rays, then there are this is X-ray, okay. Then you know about the ultraviolet rays, and then there is our visible spectrum, then there is infrared region, and there is microwave, then there is radio waves. Similarly, that's all. Okay, so let's start with the first of all with the gamma rays, which are the most energetic. Okay, their wavelength is very low, means their frequency is very high. So the frequency of gamma rays are greater than 10 to the power 9 Hz, and their wavelength is very short, at less than 0.01 nanometers. How small this factor is, because wavelength is 0.01 nanometer, so the frequency is very high, which is 10 to the power 9 Hz. And their source, where it comes from, this gamma rays basically comes from the nuclear reaction and cosmic phenomena. Okay, and their applications is we can cure cancer, we can cure any tumor inside human body, stabilize mechanical medical equipments, because these are very short in wavelength. We can easily penetrate these into human body, but the drawback is that these are the most energetic. They can damage human tissues. Okay, that's why in hospital or in medical applications, doctors do not use gamma rays. You know, doctors use X-rays, because X-rays somehow less energy than gamma rays. If doctors use gamma rays, then patient instead of cure they got die, because those tissues got totally keysed due to the exposure of the most energy. Okay, so now move on towards the X-rays. X-ray has less energy than gamma ray. Its wavelength is now of range of 0.01 to 10 nanometer. Okay, gamma rays range of 0.01 nanometer, but now the wavelengths somehow increase a little bit, like 0.01 to 10 nanometer. Okay, and frequency also now decrease somehow. Now the frequency ranges between 10 raised to power 17 to 10 raised to power 19 hertz. Okay, and the source of the X-ray are basically again the nuclear reactions and the cosmic phenomena in you can see in stars and in space. Okay, so the applications of X-rays are we can mm, cure it in medical for imaging. We know you know that in you are going to hospital for X-rays for medical images or security cameras you can use because these are energetic waves. These can penetrate inside your body. Okay, easily. Now move on towards the UV rays, ultraviolet rays. Okay, these has now a range of wavelength from 10 to 400 nanometers. Okay, and the frequency is now again somehow decreases up to 10 is per minus 15 to 17. Gamma rays has a frequency range of 10 is per 19. Then we move on to X-ray, which has 10 is per 7 to 19, 17 to 19. Now the ultraviolet has the frequency range of 10 is per 15 to 10 is per 17 hertz. Okay, and the wavelength is this from 10 to 400 nanometers. And the source of UV rays are basically there; those are coming from sun, and UV lamps are also there. Okay, and the applications are this: we are using this for fluorescence in our TVs or stabilizing anything. Okay, so now move on towards our next, which is the visible light. So visible light is basically light in the range of between 400 nanometer to 700 nanometer. This is the only range which our human eye can watch. Okay, and the frequency range is now again decreases from this up to from 10 4 multiplied 10 is per 14 to 7.5 into 10 is per 14. Basically, a factor of 10 raised to power 14 is in the visible region, okay, between 4 to 7.5. Understood? And the source of the visible light is sun and light bulbs we made, okay. And applications are human vision, photography, illumination. We take photos and either everything else. Now move on towards the infrared, IR. Understood? First of all, UV, okay, X-ray, then UV. Now move on towards the IR. So IR now has a range of 700 nanometer to 1 millimeter. Okay, you can see wavelengths got increase and increase. So there is an increase now. Nanometers convert into millimeter. Okay, and frequency now again comes inside a range of 10 is per 11 to 14 hertz. Okay, and the source of IR is heat emitting objects. IR lamps is also there. So heating objects sometimes produce IR radiations, okay, infrared radiations. Understood? And they are in your remote. So the applications are remote controls and remote of your TV, your either your everything else, your AC or thermal imaging or heating devices. Okay. Now move on towards the microwaves. Now microwaves, you can see their wavelength got increased more in from millimeters to meters. So 1 millimeter to 1 meter. How the most increase in the wavelength? Okay. Now you can see the frequency range again. It from 10 3 multiplied 10 is per 8 to 3 multiplied 10 is per 11. Okay. And the source of the microwave are microwave ovens and radars are there we use in cooking and communication system. Okay, And last is the radio wave, which has the very most larger wavelength, which is the, you can see, 1 meters, greater than 1 meters. And its frequency is less than 3 multiplied 10 raised to power 8 hertz. You can see this is basically 3 lakhs. You can see its frequency is hertz. Okay, so this is the frequency of radio wave, and this is the longest wavelength, which is the greater than 1 meter is the wavelength of the radio wave. And the source of the radio waves are basically the radio transmitters and antennas, वगैरह. Okay, and radio broadcast we used in TV signals and mobile phones. So now move on towards our multiple choice questions, which are the most repeated past EST physics exams test preparation. So first of all, which part of electromagnetic spectrum has the shortest wavelength? The shortest wavelength we have is the gamma rays, because those are the most energetic. Okay, which type of electromagnetic radiation is used in medical imaging to see inside the human body? We are using X-rays to do this procedure. So visible light is found between two types of electromagnetic waves in a spectrum. So visible light is found between which two types of electromagnetic waves? So visible region is found between infrared and ultraviolet. So the correct answer is C. Understood? UV and infrared. Okay, first of all UV, then infrared. Inside there is a visible, you can see. Correct. What is the primary source of the ultraviolet rays? We know that the sun is the source of the ultraviolet rays. Which of the following electromagnetic wave has the shortest wavelength? The shortest wavelength we know that is the which has the shortest wavelength. The frequency is telling about the longest wavelength. Sorry. So the longest wavelength we know that is the radio waves, while your gamma rays has the shortest wavelength. Okay. Which type of electromagnetic radiation is commonly used in remote control? We know that in remote control we are using infrared, IR, not UV. Okay, UV is coming from sun. So we are using in remote controls are the IV, infrared. Which type of wavelength range of microwave? So microwave has some long some long wavelength between meters to millimeters, so we can say this answer is correct, because meters to millimeter is a range between of microwave, and nanometers to this is some high. Okay, so correct answer is this. Which type of radio electromagnetic radiation has frequency range of 10 raised to power 15? Frequency range of 10 raised to power 15 means, first of all, we see that the frequency started from 10 raised to power minus 19 to 17 in case of gamma rays, and in case of X rays, it reduces to 10 raised to power 15, 17 to 15. I think it's then again it's moves from uh, and then we have to move on ultraviolet, and ultraviolet has a range of 15. So I think correct answer is the correct answer is ultraviolet. Okay, so as you can see, we discussed in ultraviolet that its frequency lie between 10 raised by minus 10 raised by 15 to 17. In this, in gamma rays, it's basically 10 raised by 19, but in X-rays, 17 to 19, but in ultraviolet, it's 15 to 17. Okay, and in visible, it remains constrained at 10 raised by 14, and then it reduced to 10 raised by 11 to 10 raised by 14, then this is 8 to 11, and then it should retain at 10 per 8. So these are the main differences you should have to remember. Okay, so this range is in the UV rays. So what is the wavelength range of visible? So the wavelength range of visible, we know that it's between 400 to 700 nanometers. Some books mentioned between 350 to 650. This is also right. Okay, no problem. So which type of electromagnetic radiation is used in radars and microwaves? So those are the microwaves that are used in the radars and the microwaves. Okay, so that's the correct answer. Okay, so now move on towards the properties and applications. So for that, first of all we have the definition, brief definition about the properties and applications of electromagnetic waves. So we already know that electromagnetic waves are basically the waves which do not require any medium to propagate, and those are the fluctuations of electric field as well as the magnetic field. Okay, and they do not require any medium to propagate. So their key points are speed, wavelength, frequency, energy, amplitude, or transverse in, and those electromagnetic waves are transverse in nature. Means electromagnetic waves are transverse, meaning that they oscillate perpendicular to the direction of propagation. Okay, and electromagnetic waves exhibits both wave-like duality, wave-like as well as particle-like. So electromagnetic waves are wave duality in nature. Keep remember this thing. This is very crucial point. Mostly this comes in your exams. Okay, this is very important. So your electromagnetic waves is a dual in nature. It behaves wave duality, wave particle duality. It will behaves like particle as well as the wave. So principles of we already discussed about gamma rays, X rays, ultraviolet rays, UV, visible, infrared, okay, and microwaves and the radio wave, which has the most longest wavelength, lowest frequency, and the lowest energy, because wavelength and energy has the inverse relation and wavelength frequency has the inverse relation. That's why. Okay. Now move on towards our main MCQs, which are the most repeated past EST Physics exam test MCQs. By doing these, you will easily secure 90% of your test. Okay, so if you need these notes physically, I will definitely provide you. I will left my number in the description below. You can directly contact me. I will provide you in a very little price. Okay. We will also cover all these lectures in our YouTube videos. If you don't like to buy those notes in a little price, then you can watch those videos. Okay, we will also upload all the lectures in our channel. Okay, which type of electromagnetic wave is commonly used to sterilize medical equipments? So in medical equipments, which type of wave is commonly used to sterilize medical equipments? Now, what does this sterilize means? Sterilized basically means जरासीम से पाक करना. So, which type of electromagnetic wave is commonly used to sterilize? So, to sterilize basically we have to need of the highest energetic wave. So, the highest energetic ray is the gamma rays. That's why to sterilized equipments we use gamma rays. Understood in medical. Keep remember very important MCQs. Okay. Which property of electromagnetic waves allow them to travel through vacuum? Those are the transverse waves that travel through vacuum. Your longitudinal waves do not travel in vacuum. Okay, only your light waves, your transverse waves, because light is also a transverse wave. You can say only transverse wave travel through the vacuum. Okay, correct. Which of the following electromagnetic wave has the highest energy? So the highest energy has the gamma rays. Which type of electromagnetic wave is used in night vision devices. So in night vision devices we use infrared, because infrared is also used in the remote sensing devices, remote controls. What is the primary application of microwaves in communication? So we use microwaves in sterilization? No. Sterilization we use gamma rays. Broadcasting we use in which primary application microwave in communication? No, we are not using in broadcasting for microwaves for broadcasting. So for satellite communication, yes, we are using microwaves in communication for satellite communications. So the correct answer is satellite communications. So microwaves are basically used for satellite communications. Okay. For medical imaging, we are using X-ray. For broadcasting, there is another wave. Okay. And for sterilizing is gamma rays. For satellite communication, we use the microwaves. Understood? Okay. Which type of electromagnetic wave is used in medical image to create detailed image of bones? So to create images of bones, we use X-rays. Okay, because we use X-rays. We are not using the most energetic gamma rays because they damage the tissues of our body. Visible light is primarily used for which of the following application? Cooking, communication. For cooking, we use microwave. For communication, we use radio waves, or so you can say the again microwaves. For illumination, for sterilizing, we use the gamma rays. For illumination, so correct answer is C. To see the objects, to we use the visible light. Okay. Which type of electromagnetic radiation is used to remote and remote control TVs? So it's the IR radiation. Okay. Which type of electromagnetic waves has longest wavelength? So the longest wavelength has the radio waves. Okay. Because these are the lowest in energy, so it has the longest wavelength. Understood? Which type of electromagnetic radiations is used in radars to detect objects and to measure the distance? These are the microwaves we use in radars, or to cook foods we use the microwaves. So the correct answer here is the C, microwaves. Okay. So that's all for this chapter number 5. We cover this for the our chapter electromagnetic waves and radiations. So that's all for today's lecture number 5. Okay. We will upload more interesting videos in our upcoming lectures. So this is our chapter number 5. We already covered this wave motions. In wave motion, we detail cover all these subtopics: mechanical waves, electromagnetic waves, and surface waves. Okay, and we discussed all the key points and their relevant MCQs. So that's all for today's lecture number 5 of FDE EST Physics Past MCQs, which are the most relevant, most unique, and the most claimed MCQs in past EST physics exams. By doing these MCQs, you surely got 80 to 90% score in your exam. Okay, we should cover all these in our coming videos. We will also cover pedagogy problems as well as the English part in our upcoming lectures. Along with that, we will also cover biology section, mathematics, sciences, physics we are doing, and along with that, chemistry and English, Islamiyat, Urdu. We have already ready-made notes for you. Like you can see, these are the combination of physics notes of total 96 pages. This is basically the all better for you. By doing these only, you will easily score 80 to 90% in your exams. We should cover all these, but if you want these all notes of pedagogy, of English, of or any other subject, we will provide you. We have ready-made PDFs for you. If you want, you can just leave your comment below along with your email. We will definitely send you by email, or you can also contact by direct contacting me on my WhatsApp number. I should left in the description below. So I should provide you all these notes in a very little price. So you can contact us. So thanks for watching. In our upcoming video, we will continue our next chapter number 6, which should be about let's check about optics. Okay, in our upcoming video, we should cover this chapter optics, which is very important for FDE EST exams. So till then, take care. Don't forget to like and subscribe our channel and share with your friends who are going to be appear in the FDE EST physics exams. Till then, take care. Allah Hafiz.